In this lesson, we'll explore the base 10 or common logarithm, and we'll look at how to compute values of logarithms using the common logarithm. Base 10 logarithms are often used in computations since our number system is base 10. We call the base 10 logarithm the common logarithm, and we typically abbreviate the base 10 logarithm, or the log base 10 of x, as just log of x. So when we just write log x, we mean the base 10, or the common log of x. And you should notice on your calculator that your calculator will have a button log, and this refers to the base 10, or the common log. Let's look at a few examples of the base 10 or common logarithm. So if we have the exponential equation 10 to the x equals 100, we know that x is equal to 2 because 10 squared is equal to 100. In logarithmic form, we write this as x is equal to the log base 10 of 100, or just the log of 100, which again we know is equal to 2 because we know that 10 squared is equal to 100, so our x is equal to 2. And on your calculator, if you enter log, that log button, and then type 100 and enter, you'll get the value of 2. As another example, suppose we have 10 to the x equals 3. Here now we're not going to be able to solve this exactly like we did in the previous example, but we can rewrite this exponential equation in logarithmic form as x is the log base 10 of 3, or just x is the log of 3. And again, using your calculator, use the log button and then 3 and then enter, and we get approximately 0.477. And you can check this if you do again on your calculator, 10 to the 0.477. Of course, this is an approximation because we only looked at the first 3 decimal places here when we did log 3 on the calculator, but we will get approximately 3 when you compute 10 to the 0.477. So one more example of this common log, or log base 10. If we have 10 to the x equals 0.2, this exponential equation can be rewritten in logarithmic form as x is the log base 10 of 0.2, or just log of 0.2. And again, when we approximate this on the calculator using the log button, we get approximately negative 0.699. Again, you can check this, do 10 to the negative 0.699, and we get approximately 0.2. So the key information so far is that when we write just log of x, we're referring to the base 10 log of x, so the log base 10 of x, and we'll call this the common logarithm. The reason we often use this common logarithm, or base 10 log, in computations is because the number system that we work with is a base 10 number system. So now let's look at how to use this the common logarithm, to solve exponential equations. So let's go back to that first exponential equation that we looked at that we couldn't solve by writing both sides as a common base. 2 to the x equals 5. Now we know that in logarithmic form, we can rewrite this exponential equation as x is equal to the log base 2 of 5, but we want to figure out how to get a decimal approximation for this using our calculator, so using the common logarithm. So we have our 2 to the x equals 5, and now we know that using our properties of logarithms, so we know that b to the log base b of y is equal to y. So this is one of the properties of logarithms that we've looked at and explained or proven previously. So in particular, 10 to the common log, or the log base 10 of 2, is equal to 2, and 10 to the common log, or log base 10 of 5, is equal to 5. So we're using this property of logarithms that we looked at previously with a base 10, our common log, and in this first equation, we're applying this property with y equals 2, and in this second equation, we're applying this property with y equals 5, and again, in both cases, we have a base of 10. So we'll do that to replace on the left-hand side 2 with 10 to the log 2, and 5 with 10 to the log 5. So 2 to the x becomes 10 to the log 2 all to the x, and our 5 is just 10 to the log 5. Now we'll use our properties of exponents, and we know that the log 2 and the x multiply, so we get 10 to the x times log 2 is equal to 10 to the log 5. Now we've written our equation as an equation where each side has a common base, so we have a base of 10 on both sides of this equation. We can now equate our exponents, so we get that x times log 2 is equal to log 5, which gives us that x is equal to log 5 divided by log 2. And again, remember, these are our common logarithms, the log base 10 of 5 over the log base 10 of 2, and that's because here, when we used our properties of logarithms, we were using the base 10 or common log. So we have x is log 5 over log 2. We can now use the log button on our calculator to compute this. So again, the base 10 or the common log 5 over base 10 or common log of 2, and we get approximately 2.322, which you can check again by doing 2 to the 2.322 on the calculator, and we get approximately 5. So in other words, we can conclude that the log base 2 of 5 is approximately 2.322. And so the key ideas to take away from this example are that we were able to rewrite this base 2 logarithm. We don't have a base 2 button on our calculator as a common logarithm, log base 10 of 5 over log base 10 of 2.